Hey, good day, good people. Let us look at compound bar. Let us look at compound bar. All right. Compound bar is the combination of two different types of material, either connected in series or connected in parallel. Now, on the first part of your compound bar, we will be dealing with the expansion of the compound bar uh, due to the applied force. The first part of compound bar, we deal with the extension of the material as a result of what? Of force applied. Meaning we are dealing with the change in length as a result of what? Of the force applied. Now, let us look at the first connection here. We are looking at the series connection. Now, when you are dealing with the series connection, this is what you need to know. You need to know that length total equals to length 1 plus length 2, right? Length 1 plus length 2, then you get the total length of the whole compound bar. Right. Now, when calculating the change in length, when you calculate the total change in length, it will be xt equals to x1 plus x2. Right, because when the force it's been applied, whether they are applying the compressive or the tensile force, this is what you would realize. You would realize that the force applied, and this would be your force total. Right. This would be your force total. The force applied on your series connection, it is your total force. You'd realize that that force, it will have the effect on unit 1. It will have the effect on unit 2. Hence, the change in length, we will have the change in length on unit 1 and the change in length on unit 2. Then we get what? The total change in length. Now, how do we then calculate the total change in length when we are having the series connection? We will be using this formula: x equals to force multiplied by distance divided by area multiplied by Young modulus. See, that means under your xt you will have this formula here plus them, then you will be able to then calculate your change in length. Now, this formula again, it can be written as stress multiplied by L over E, because here you are having, how do we calculate stress? It is force over area, and you can tell that here we are having force over area. Hence, you can either calculate your change in length as x multiplied by L multiplied by E. If you are given the stresses, then you can use this formula to calculate your total change in length. That means here you will have, let's write all the formulas. Let's write this formula in length. It is xt, f1, L1. Now, F, it is common because it is Ft over area. Then E, it is common as well if it is the same type of material. Then you are having F common, L2 over area 2. This is area 1 multiplied by E common. Or you can have stress 1 L over E plus stress L2 over E. Right. It will depend what you are given. Now, another thing that you need to make note of under your series connection is that Ft equals to F1 equals to F2. Right, because the total force affect unit 1, unit 2. Now, if that's the case, you are having F1 equals to F2. We know that if you are dealing with, let's say, you are calculating total change in length, or you are given the stresses, it then means here F1 equals to F2. It then means here we will have stress 1 area 1 equals to stress 2 area 2. Then you can make any of the components here, the subject of the formula, more especially if you are only given or if you are given the stresses, you are dealing with the change in length from the stress perspective. It means this would be Papa unit 1 and equation 1, then this would be equation 2. Then from there you'll have equation 1 equals to stress 2 A2 over area 2. This one's most probably you would have been given. Then it will be area 2 divided by area 1 multiplied by stress 2. Then you come and substitute your stress 1 here. Where the stress 1, you put stress 2 plus the ratio of your areas there. Then you will be able to then solve whatever that needs to be solved. If they want you to calculate the stresses, more especially the stresses there, then if you it means if you are taking this route, you will be given the xt. Maybe they want stress 1 and stress 2, then you can apply that formula. But other than that, this formula, it is applicable, right, in calculating your stress, force over area, right? It is applicable. Now, under your series connection, this is what we are dealing with, good people. And another thing, under your series connection, you are having strain total equals to strain 1 plus strain 2. How do we calculate the strain? Strain, it is the change in length over LO. Or the strain as well, it can be Young modulus equals to stress over strain, whereby you make strain the subject of the formula. It is stress over Young modulus. It means here you can either use this part of the formula or you can use this part of the formula for your strain. It will depend what's given. This is what we are dealing with under your series connection, dealing with the change in length as a result of the applied force. Now, let us look at the parallel connection. Now, the first thing that you need to note under your parallel connection, you are having two different types of material connected together, whether welded or they've used the rivets or whatsoever to join them together. The first thing that you need to note is that you are having different types of material. Now, if the force applied, it is the tensile or compressive. That force applied there, it is the total force. Right, it is the total force. Now, how this material 1, it's going to absorb the total force. It's not the same as material 2, how it's going to absorb the force. Let's say this is steel and this is copper. Between the two material, we know that steel, it is harder, it is hard comparing to what, to copper. It then means if the force it is applied under your stress and strain graph, if the force it is applied, you'd realize that let's say they've applied 100 kilonewton under this material. You would realize that under that force, the copper will start to deform quicker comparing to what, your steel. This would be the graph, the Young modulus graph for what, for copper, because remember, Young modulus indicates the strength of the material. Now you'd realize that copper will bend quicker than steel. When the force has been applied, then you realize that steel, it bends on a later stage. Boom. This is where it turns. This is your E for steel, and this is the E for copper. All right. Now, as a result of this, obviously, the force total, that indicates to you, therefore, that your force total would be force copper plus force steel. Why? Because how force will absorb the force total, it is not the same as how steel will absorb that force total. Now, under the parallel connection, this is what you'll be dealing with here. Now, let's deal with force and finish and deal with the formulas that we know under your force. We know that stress, it is force over area. Then if we were to make force the subject of the formula, we are having stress over area. You can deal with this formula if they want you to deal with it from the force perspective or the stress perspective, then you are having a stress 1 area 1 plus stress 2 area 2. Right. If you are given what the stress is, you can deal with this formula from the stress perspective. Now, another thing that we know under the parallel connection is that the change in length will occur simultaneously under the both material. That means change in under your steel, it is the same as change under your what? Under your copper, because they are connected together. It means the change will occur concurrently or simultaneously. So right now we know that force 1 L1 over area 1 E1, the E will be different because it is different types of material. Then the force 2 length 2 over area 1 area 2 E2. Now this is the formula that we'll be dealing with. Now this formula as well, it is the formula of change. Now if we are dealing with this from the stress perspective, we know that here we'll have stress 1 L1 over E1 equals to stress 2 L2 over E2. But here we know that under parallel connection, L1 equals to L2. That is the condition that we have under the parallel connection. That means here the L and the L will cancel out. The L and the L will cancel out. Then you'll have stress 1 over E1, stress 2 over E2. Now, under your parallel connection, this is the formulas that we'll be dealing with when the force it's been applied, dealing with the change in length as a result of the force applied. This is what we'll be dealing with. This part, it is the part that deals with what? With the force applied. And these are the formulas that we'll be dealing with to calculate whatever that they want us to calculate. Now, before we can even apply the third part, let's look at the what's this? Let's look at the different types of parallel connections. Let's look at the different types of parallel connections. Let's look at the different types of parallel connections. Right. Look at different types of parallel connection. Now, it doesn't matter what type of a parallel connection you are given. You will address it you will address it based on the formulas that we touched on the first slide. Now, right. We are having different types of parallel connection. We are having the one that we dealt with now. Having something like this. Right, it is your parallel connection. Right, whether it is FT which has been applied, you are having steel, you are having copper, parallel connection. Another type of parallel connection that we have, we are having something like this. When you are having the ropes hanged on your ceiling, the ropes hangs on your ceiling. It doesn't matter. As long as it's a parallel connection, you will apply similar principle. Right. You will apply similar principle. Let's say this is copper, this is steel, this is copper. It is still a parallel connection there. This one as well, it is parallel connection. Right. Another parallel connection, if you are given the pipe, you are given the pipe, right, you are given the pipe, then you are having a solid substance in there. Let's say this is your copper, then the inner, it is your steel. It is still parallel connection. It doesn't matter what parallel connection you are given. As long as it's a parallel connection, the principles they stand. If it's a parallel connection, x1 equals to x2, then ft equals to f1 plus f2. This is what we'll be dealing with. It doesn't matter whether we are given the concrete, whether we are given the concrete in a form of column, then we are having reinforcement steels. We are having the reinforcement steels. It doesn't matter. These are the reinforcement steels, right? Reinforcement steels. Then this is your concrete. Then this is your steel. It doesn't matter. It is still the same thing. Parallel connection. We will deal with it based on the formulas that we touched on. Yeah? This is your parallel connection. These are different types of your parallel connection. It doesn't matter whether you are given straps. It doesn't matter. You are given the straps. It doesn't matter. These are your straps. It doesn't matter. It is still same principle, parallel as well. The only parallel that we have, and it is dealt with as if you are dealing with you are dealing with this type of a parallel connection as if you are dealing with you will be using the series principle in dealing with this parallel connection. It is the only parallel connection that we are dealing with it using the series principles, right? It is the only parallel that we are dealing with. If you are given something like this, it's a parallel connection. That is the only one. You are given a tube, right? You know me and drawing, and beside my thingy there, right? Then you are having bolts or nuts there. It doesn't matter, right? The inside part of it, right? Okay. Now you are given something like this, né? Let's say this is your PVC, then this is your bolt. Let's say this is your bolt, right? This is your bolt, right? Then this is your nut. Now, this it is considered a parallel connection because you are having a PVC, you are having a bolt. They are in parallel connection. Now, the force here, which it's been applied, it is the force compression. Because as you are turning your nut, you are applying what? The force, right? As you are applying, you are turning your nut, you are applying what? The force. You are compressing the PVC. And what's going to happen to the bolt? The bolt is going to be extended. The bolt is going to be extended because the nut is going inside. As the nut is going inside, you'd realize that this bolt, the bolt here, it will be what? It will be extended. The bolt here, it will be what? It will be extended. As you are doing what? As you are applying as you are applying the compressive force by turning what? The nut. Now here you are having xt equals to x1 plus x2. Then you are having force 1 equals to force 2. Because if you are making number of turns here, if you are turning the left hand side, you are making 3 turns. You are applying the force. As well as this side, you have to turn what? 3 turns. That means you are applying what? Equal force. That is why force 1 equals to force 2. Xt equals to. Now, xt, in calculating the xt, it will be the number of pitch multiplied by number of turns that you'll be making. Now the pitch, it is the distance of what? It is the distance between your threads. Né? It is the number of pitch multiplied by number of turns, then you get what? Your xt. Now this is how we calculate the xt. But from this formula, they can ask you to calculate the stresses, or they can ask you to calculate the force. It doesn't matter. If they wanted to calculate the force, we know how to deal with it. It is F 1L 1 over AE plus FL over AE. But now here, the length, it is not the same, because if you are given the washers, if there's washers, you must then consider the thickness of washers. If you are given the washers, you must consider the thickness of washers. And the thickness of washers, you will always add them with this part, the PVC, because the inner part is going to be extended. Remember, the washer, it is something like round and it has a hole. It means this thickness, it will be added to the PVC. Then the bolt obviously will go through there. That is why you don't add the thickness with what, with that solid part, but you will add it with the, whether PVC or copper, it will depend what's given. Then here the condition is that if you are given the washers, obviously the length won't be the same, right? Then here it will be stress 1 area 1 equals to stress 2 area 2. Now this is the only parallel. This is the only parallel where you are using what? Series connection method. Method or formulas. Let's write formulas. This is the only parallel connection where you will use what? You will use the series formulas to calculate whatever that they want you to calculate. This is what we'll be basically dealing with under your compound bar. The first part, like I said, we are dealing with the total change in length as a result of the applied force. Then I will drop another video on the change in length as a result of what? Of heat. But for now, let's focus on the force applied. Then I will drop the application of it now. Thank you, good people.